My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Operating Systems as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: define file system. File system. A file system is like the library system of a computer. It is a way of organizing, storing, and managing data on storage devices like hard drives, SSDs, or USB drives. It decides how files are named, saved, found, and accessed. When you save a photo, video, or document, the file system stores it in a structured way so you can easily open, edit, or delete it later. Example in simple words. Imagine a library. Books is equal to files. Shelves is equal to folders, directories. Library catalog is equal to file system index. Without this system, books would be scattered everywhere and impossible to find. Similarly, a computer without a file system would be chaos. Popular file systems: NTFS, Windows. Extension 4, Linux. Apps, Mac. Summary: a file system keeps data organized and accessible, making computers work like a well-arranged library rather than a messy pile of files. Next important short question is: 2. What are the different file access methods? File access methods. A file access method tells the computer how to read or write data stored in a file. Think of it like choosing how to read a book from start to end by skipping pages or by looking up a specific chapter. Types of file access methods. 1. Sequential access. Data is read or written in order, one record after another. Example, watching a movie, you start from the beginning and go step by step. Used in music or video players. 2. Direct, random access. You can jump directly to any part of the file. Example, jumping to a specific YouTube timestamp. Used in databases. 3. Indexed access. File has an index like a book's table of contents, so you can quickly find data. Example, searching a word in a dictionary. Summary: file access methods decide how fast and easy it is to find or store information, making computing smoother. Next important short question is: 3. What is a directory structure in an OS? Directory structure in an operating system. A directory structure is like a digital cupboard where files are stored in an organized way. In an operating system, OS, a directory is a special file that contains the names and details of other files. This makes it easy to find, add, or manage files. Types of directory structures. 1. Single-level directory. All files are kept in one folder. Example, everyone in a house keeps clothes in the same cupboard, hard to find things. 2. Two-level directory. Each user has their own folder. Example, each family member has their own cupboard. 3. Tree-structured directory. Directories can have subdirectories, forming a tree-like structure. Example, a cupboard with many shelves and drawers. Summary: directory structures make file management organized and easy, just like arranging books in a library. Next important short question is: 4. Explain file protection. File protection in operating systems. File protection means keeping files safe from unauthorized access or damage. Just like locking your cupboard to protect your things, an operating system, OS, uses file protection to control who can open, edit, or delete a file. Why file protection is needed? To stop others from accidentally deleting or changing files. To protect sensitive data like passwords or project work. To prevent malware or hackers from harming files. Methods of file protection. 1. Access control. Each file has permissions. Read or open the file. Write W change the file. Execute X run the file. Example, in Windows, right-click a file, Properties, Permissions. 2. Passwords. Set a password to open or edit files. 3. Encryption. Convert data into a secret code. Example. A company's payroll file can only be read by HR, updated by the manager, and is hidden from others. Next important short question is 5. What is a mass storage structure? Mass storage structure in operating systems. A mass storage structure is a way of storing large amounts of data permanently on devices like hard disks, SSDs, CDs, DVDs, and USB drives. Unlike RAM, which is temporary, mass storage keeps your data safe even when the computer is turned off. The operating system manages this storage by organizing files, allocating space, and keeping track of where data is saved. Key features. Large capacity can store huge amounts of data, GBs, TBs. Non-volatile data remains safe even without power. Multiple levels includes hard disks, fast, large, and optical storage, DVDs, Blu-ray. Example. Your laptop's 1 TB hard drive is a mass storage device where movies, games, and documents are stored permanently. Remember, mass storage is like a big library where the OS acts as a librarian, helping you store and find your data efficiently. Next, Unit 3. Long questions. First important long question is 1. Explain file allocation methods with diagrams, contiguous, linked, indexed. File allocation methods in operating systems. File allocation methods are ways the operating system, OS, stores files on the disk. The OS decides where and how file blocks are stored so that they can be accessed quickly and efficiently. There are 3 main methods. 1. Contiguous allocation. In this method, all blocks of a file are stored next to each other. It's fast for reading because the disk head doesn't move much. Problem: files may not fit into a single continuous space, leading to fragmentation. Example: a movie file stored from block 10 to block 50 in one stretch. Diagram: 10, 11, 12, 13, 14. 50. File stored in sequence. 2. Linked allocation. Each file is a linked list of disk blocks scattered anywhere on the disk. Every block has a pointer to the next block. Advantage: no need for continuous space. Problem: slower access because the OS must follow pointers. Example: a file stored at blocks 5, 29, 15. Diagram: 5, 29, 15 pointers connect blocks. 3. Indexed allocation. The OS creates an index block that stores all addresses of file blocks. Advantage: fast random access because all addresses are in one place. Problem: extra space is needed for the index. Example: index block points to file blocks 3, 8, 12, 30. Diagram: index block 3, 8, 12, 30. Summary table. Method: speed space use best for. Contiguous very fast may waste space large files in one piece. Linked slow efficient use sequential access. Indexed fast random extra index space quick random access. Next important long question is 2. Discuss file system implementation in detail with examples. File system implementation. A file system is a method used by an operating system, OS, to store, organize, and manage files on storage devices like hard disks, SSDs, and USB drives. It decides how data is saved, retrieved, and protected. 1. File control structures. The OS maintains structures to track file information. File control block, FCB, stores details like file name, size, location, creation date, and permissions. Directory structure, a table that lists all files and their FCBs. Example, think of your phone's gallery. The folder name is like a directory, and each photo has details, size, type, date. 2. Disk storage management. To store data efficiently, the OS divides disks into blocks, fixed-size storage units. 3. File allocation methods. Files are stored on disk using one of these methods. 1. Contiguous allocation, stores file blocks one after another. 2. Linked allocation, stores file blocks anywhere, linked by pointers. 3. Indexed allocation, uses an index block to store all file block addresses. Example, a music file might use contiguous allocation for fast playback. 4. Free space management. The OS must track empty blocks to store new files. Bitmap method, 0 means free, 1 means used. Free list, a linked list of available blocks. 5. Directory implementation. Directories can be single-level, all files in one place. Two-level, separate directories for each user. Tree structure, folders within folders, like Windows Explorer. 6. Protection and access control. The OS uses permissions like read, write, and execute to protect files from unauthorized use. In simple words, a file system is like a library system. The catalog directory lists all books, files. Each book's details, FCB, tell you where it is. Shelves, disk blocks, hold the data. The librarian, OS, ensures books are placed, tracked, and protected. Example. Windows uses NTFS, Linux uses extension 4, and pen drives often use FAT32. Next important long question is 3. Describe directory implementation techniques in operating systems. Directory implementation techniques. In an operating system, OS, a directory is like a table that stores information about files, such as their names, sizes, locations, and permissions. The way this directory is designed and organized is called directory implementation. It helps the OS quickly find, create, delete, and manage files. 1. Single-level directory. All files are stored in one single directory. Easy to implement but becomes confusing if many users store files with the same name. Example, a small USB drive with only one folder for all files. 2. Two-level directory. Each user gets their own directory. Files with the same name can exist in different users' directories. Example, Windows gives every user their own documents folder. 3. Tree-structured directory. Directories are organized like a tree with folders and subfolders. Easy to group related files and navigate. Example. Your laptop has c:/users/name/documents/college/notes. 4. Acyclic graph directory. Allows sharing of files and folders between different users or directories. Avoids duplication by creating shortcuts or links. Example, a shared folder on Google Drive that many users can access. 5. General graph directory. Similar to acyclic graph but allows cycles. Needs special care to avoid looping while searching for files. Example, advanced file systems in servers that allow complex linking. How directories are implemented. 1. Linear list. Stores file names in a simple list. Easy to create but slow to search. 2. Hash table. Uses a hash function to quickly locate files. Faster but needs more memory. In simple words, a directory is like the index of a library. A single level is one big shelf. A tree structure is like categorized shelves. A graph directory is like having books linked in multiple sections. Example for memory. Think of your phone gallery, albums are directories and photos are files. Next important long question is 4. Explain the structure of I/O systems in detail. Structure of I/O systems. An input-output I/O system in an operating system is the part that manages how data moves between the computer and external devices like keyboards, printers, hard drives, and networks. It acts as a bridge between hardware and software, so users don't have to worry about the technical details of device communication. Main components of an I/O system. 1. I/O hardware. Includes physical devices, keyboard, mouse, printer, disks. Each device has a controller that manages its operation. Example, a printer's controller converts digital text into printable commands. 2. Device drivers. Software that tells the OS how to communicate with a device. Each device has its own driver. Example, a USB driver helps the OS recognize a pen drive. 3. I/O scheduling. Decides the order of I/O requests to avoid delays and improve performance. Example, if 3 print jobs are waiting, scheduling decides which one prints first. 4. I/O buffering and caching. Buffering, temporary storage to smooth speed differences between CPU and devices. Caching keeps frequently used data in fast memory for quick access. Example, videos load smoothly due to buffering. 5. I/O interface. Provides a uniform interface so all devices are accessed in the same way even if their hardware is different. 6. Interrupts. Devices send a signal, interrupt, to the CPU when they are ready, so the CPU doesn't waste time waiting. Example, keyboard sends an interrupt when you press a key. I/O system layers. 1. User level. User programs request I/O operations, like opening a file. 2. System call interface. Connects user requests to the OS. 3. Device-independent OS software. Provides common functions for all devices. 4. Device drivers. Communicates with hardware. 5. Hardware, actual devices. In simple words, think of the I/O system as a delivery service. User is equal to customer. System calls is equal to order request. Device drivers is equal to delivery person who knows the route. Hardware is equal to actual car or bike delivering the package. This layered approach makes it easy to use any device without knowing its internal details. Next important long question is 5. Describe the file system structure with neat diagrams. File system structure. A file system is like a library system for a computer. It organizes and manages how data is stored and retrieved on storage devices like hard drives, SSDs, or pen drives. Without a file system, your computer would just see storage as one big block of data, making it impossible to find specific files easily. To make storage organized and easy to access, the file system is divided into layers, each with a specific role. Layers of file system structure. 1. Application programs, where users interact with files using applications, Word, browsers, etc. Example, when you save a document, this layer passes the request to the OS. 2. Logical file system, manages file names, directories, and permissions. Keeps track of what each file contains and who can access it. Example, file names like notes.txt are stored here. 3. File organization module, decides how files are logically placed on disk blocks. Handles free space and allocation methods, contiguous, linked, indexed. 4. Basic file system, sends simple commands to I/O devices to read or write data blocks. 5. I/O control layer, uses device drivers and interrupt handlers to talk directly to storage devices. 6. Storage devices, the physical media, hard disk, SSD, USB, where data is stored permanently. Diagram. Application layer user interacts, save, open. Logical file system manages names, permissions. File organization mod, decides placement of data. Basic file system reads, writes data blocks. I/O control layer device drivers, interrupts. Storage devices actual hardware. In simple words, the file system is like a library. Bookshelves, storage devices, store books, data. Library map, file organization, shows where to place books. Librarian, I/O control, fetches the books. User, application, only asks for the book by name. This structure hides complexity, making file access simple for users and apps.